Hello, students. Here's the article I want to share with you this week. I tend to harvest them, and at least the ones I think are interesting, and I show them later. And because of all the stuff that's going on, geopolitically, I took a sidetrack to that. But I'm going to go back to cool science. So let's look at this article. It's talking about how using an imaging technique to look at a specific chemical reaction in real time within the cell. So some background on this, the way that we normally do biochemistry is we take cells or whatever we're studying, typically for cells for living creatures, and we crush them or do something. We take out the biomolecule that we are interested in, and we take it out of the cell, we isolate it, and then we carry out the reaction outside of the cell. Now, the issue with this is, it should work this way, but the question is really the way it happens inside of a cell? So, we're taking the molecules outside the environment of the cell, and in doing so, are we damaging the molecule? And is there a different environment? What are we really sure that we're doing this the proper way, and this is really what we're studying, and is this the real effect, or is it completely different in the cell? But now, if we have the ability to image things and image chemical reactions in the cell, besides the fact they make cool pictures, right? These are pretty pictures. And here's the mitochondria, the powerhouse of the cell, as everyone remembers from at least my freshman biology class. But now, this is actually the mitochondria, and this is the mitochondria inside of the cell. So we're imaging molecules inside of the mitochondria, inside the cell. We're not isolating them. We're not taking them outside of the environment. We're looking at the reactions this way. So this is what's really interesting about this technique. And if you look at what they're looking at, so looking at tetrazine, ligation, and so if I can hear some of these words. So the fact that we're doing this, and like why this doesn't seem to be that interesting. And there is some applications if you read the article that may be looking at some pain medications, but the whole point of this, though, is that the fact that they're doing it inside of the cell as the cell is alive and as the cell is working. So this way, there is no question that we have previously, is isolating this, is this changing things? So this is chemistry happening, and we're studying kinetics, we're studying the chemical reactions inside of the cells as they're happening. So it's really interesting. This is amazing. So science is amazing. It's becoming more amazing. So and this is one of the ways that it's doing it. I know I've been talking a bit about machine learning and how we're using machine learning in the past 2 weeks, and now we're looking at things as they happen properly inside the cells rather than isolating them. So that's kind of the background if you haven't don't know the kind of the context in which we typically do biochemistry research. So here's like I said, an article for you can read, and if you're hopefully pique your interest and see how amazing science is. And besides science is amazing, you guys are also amazing. Of course, not every moment of your life is amazing. And if that does happen, please let me know if any of your basic needs are not being met, or if you're having academic issues. I will always do what I can to help you, and I can help connect you up with people. So please keep that in mind. And it's synergistics for the class, because if you're not doing well in other aspects, there's no way you can work to your full potential in this class or other classes. So please keep that in mind. So I will sign off for now. Happy reading. Happy weekend. Goodbye.